Hi everyone, we are Group 5 and today we will show the architecture design for our mobile platform, Grad Connect Hub. Here is our agenda. First, let's introduce Grad Connect Hub. It's mobile platform for new grads who lack work experience to confidently step into the workplace. It offers customized mentorship and networking opportunities, helping them build their professional networks easily and quickly. Next, we will proceed to architecture diagram, which displays the stakeholders involved with Grad Connect Hub and their interaction with its features. Our primary users are new grads who supported by mentor and the HR professionals. Event organizers create professional events to all platform users. The features are categorized under user profile management, mentorship management, and event management, each integrated with a central database and monitored via user activity logs. The platform team ensures the system operates smoothly. Now let's focus on our primary use case. This includes creating and managing personal profiles, searching for mentors. After that, user can schedule their mentorship session and participate in networking events. Finally, we collect and analyze feedback to enhance feature events and improve our platform. Consider users seeking mentors in their field. Our platform makes it simple. With a fully operational mentor profile database and search algorithms, users can easily find mentors who match their interests, industry, and availability, ensuring a seamless connection between mentors and mentees. Next, feedback is an important function for our improvement. After events, our system not only prompts users for their insights, but also collects feedback, providing event organizers with valuable data to refine future experiences. And the platform team also utilizes feedback to enhance the system.
The first key quality scenario for Grad Connect Hub emphasizes usability, making sure that the platform is straightforward for users at any tech level. It boasts clear interfaces for finding mentors and arranging meetings. When any users or issues arise, the system promptly guides them with clear instruction and fast results. And in terms of performance, the second scenario is all about responsiveness. The platform consistently processes user requests within 2 seconds, supported by effective load balancing to handle the demand. Security is our third key quality scenario. The platform is proactive about safeguarding personnel information, quickly responding to security risk with account blocking and stringent data protection protocols to keep users' data secure. In the Grad Connect Hub context view, we have a network of internal systems that interact seamlessly with platform. Users actively log, track, and analyze user actions, providing critical data for improving user experiences. The project management system is key for task assignments and tracking progress, which is essential for keeping the development on the target. Database management is the backbone of the system, securely storing and handling all user and system data. The development environment is where the magic of coding, testing, and deploying takes place, allowing the platform to evolve and adapt. Lastly, the requirement management system captures and updates project requirements, ensuring that all developments align with the platform's objectives. As for the users, internally we have project manager who oversee project progression. developers who maintain and update the system administrator who ensure the platform smooth operation, and a business analyst who keep the project in line with business goals. However, the external systems are represented by external companies or organizations that contribute to job listing and professional data. This partnership extends the platform capabilities and enrich the service offered to our users. The external users are a diverse group, including new graduates embarking on their career, mentors providing guidance, HR professionals on the lookout for fresh talents, and event organizer aiming to attract participants, and each of them playing a vital role in the thriving ecosystem of Scratch Connect Hub.
So moving on to reference architecture, we decided to use mobile client application as the foundation to start with. We aim to make it depends on server processing and will always be fully connected. This is also known as thin client. This architecture offers simple UI functionalities, but effective user experiences at the same time, and it can be responsible for dynamic and quick interactions. Some key requirements addressed based on this architecture, which are also some reasons for us to choose it. First of all, it provides standalone application accessibilities. And secondly, it ensures secure access to the platform for different user roles. And thirdly, it enables users to update their profile and qualifications in real time, which is something that Grad Connect Hub really needed. So based on that, we have two different iterations. The first one falls under data layer. The key drivers we consider here are performance and availability. We are trying to solve the problem of providing important updates on events, saving events and mentor info, and also managing large volumes of users when that happens. The design recommendation based on that are implementing Apache Kafka and Apache Spark. So Apache Kafka is a distributed streaming platform that is highly scalable and capable of handling high throughput event data. It can serve as the backbone for real-time data processing and event-driven architectures, making it an excellent choice for achieving the business need. While Kafka primarily handles event streaming and messaging, Apache Spark can complement it by providing powerful processing capabilities for analyzing large data sets and running SQL queries. Spark can be useful alongside Kafka to perform batch processing and interactive query over large data sets. So by implement those, on a performance perspective, Apache Kafka is designed for high throughput and low latency, which allows Grad Connect Hub to handle large volumes of event data efficiently. This means that the system can process and deliver real-time updates on events, mentor recommendations, and mentorship activities with minimal delay, which provides a responsive and seamless user experience. And on the availability side, they're fault-tolerant and distributed with built-in replication and partitioning mechanisms to ensure high availability and data durability. This means that Grad Connect Hub can rely on Kafka and Spark to maintain continuous operation even in the event of node failures or network disruptions. This ensures that user can access real-time updates and recommendations without interruptions. So moving on to iteration number 2, this one falls under business layer, specifically about business components. We're trying to consider the user engagement key drivers and trying to solve the problem of how to enhance the recommendation system to provide more accurate matches for users. And for this one, the design recommendation is to introduce TensorFlow. TensorFlow is an open source machine learning framework developed by Google. It provides a flexible and scalable platform for building and training machine learning models. By leveraging TensorFlow to develop and train machine learning models for personalized mentor recommendations, Grad Connect Hub can offer users more relevant and valuable interactions. Users are more likely to engage with the platform when they receive personalized recommendations tailored to their interests, skills, and career goals. This increased engagement can lead to higher user satisfaction, longer session durations, and also higher retention rates.
For the functional viewpoint, the user interface acts as a fourth point of user interaction, where login credentials are gathered and directed to the authentication service to verify user identity. Also, for administrators, authentication confirms their credentials before granting access to the management interface. Next, users' actions are related to data processing for processing user activities such as scaling sections or submitting job applications. A two-way connection exists where data processing stores and fetches content from the content database, and then data processing organizes and keeps both action-based and regular information in a central data storage system, ensuring the operation are consistent and the data remains intact. Also, data processing interface with external services to extend the platform's capability by interfacing with external APIs for services like calendar integration and third-party data enrichment. The notification and feedback is activated by data processing to trigger user notifications and gathers feedback and then information back to the user interface, delivering system-generated alerts and feedback requests to the end users. Administrator can influence data processing through the management interface to adjust operational parameters or content management strategies. The management interface grants administrators the authority to oversee and manipulate both the content database and the data storage. For the design decisions, firstly, a sync-client setup simplifies the end-user application, reducing the processing load and also the lower device requirements, making the platform accessible to a wide range of users. Secondly, real-time data processing for such as scaling membership sections or updating event details. This decision supports the requirement for a responsive system. Thirdly, integrating TensorFlow ensures the new graduates receive personalized membership suggestions, improving the overall value of the platform interactions. Next, relying on server-side processing ensures consistency across all user interactions. It supports the platform's need for real-time data processing and updates. And then a straightforward user interface is crucial for inclusivity, ensuring that users of all skill levels can navigate the platform. Also, the choice of a cloud-based infrastructure allows the platform to scale resources based on demand, ensuring consistent performance even during peak usage time. For the last one, this architecture promotes independently scaling and updating of different platform parts, improving our system reliability.
Okay, this is an overview of our deployment architecture where we illustrate the integration of hardware and software components that provide a comprehensive platform for new graduate and professionals. Starting from the user's point of contact, we have our device client devices with the GradConnect app, allowing users to access our services through a variety of devices, ensuring accessibility and convenience. Diving into the server side, our device web server hosts the web.war artifact, serving as the gateway to our platform's web interface. In parallel, the device application server operates the application.jar artifact containing the business logic that processes users' requests and interacts dynamically with our data. Central to our data handling is the device database server with the RDBMS environment and database.sql artifact, ensuring data integrity and swift access. Alongside, the device document server manages user documents securely, encapsulated within the user.doc.zip artifact. Our device notification center or server, equipped with notification.exe, handles timely user alerts and system notifications, keeping our users informed and engaged. Additionally, our system integrates the key device external services, including the execution email server with email.dll for reliable email communications, execution cloud storage with cloud.jar for scalable file management, and execution analytics servers with analytic.so for insightful user analytics. Lastly, the device admin console and its management console artifact empower our administrators to monitor and manage the system with precision and control. This cohesive deployment diagram exemplifies the robust infrastructure designed to provide an engaging, secure, and efficient experience for all stakeholders of the GradConnect Hub.
Now for open questions and next steps. So first, our machine learning serving platform is not prescribed. It is up to the machine learning team to choose and evaluate various solutions such as Vertex AI. And secondly, microservices architecture usually requires an orchestration system. So a few alternatives exist such as Kubernetes and PN2. So it is up to the application team to choose the appropriate solution. And thirdly, an observability stack is required to ensure our application runs smoothly and the team promptly alerted when there are outages. And finally, we need to determine the various regulatory requirements for the application, which can impact the decision to vendor or to build certain components.
That's the end of our presentation today. Thank you so much for listening.